Hello. Have you ever wondered how our modern technological precision came to be and how it has grown so fast in such a short span of time? Well, let me introduce you to the mechanical technology known as machine tools, more specifically, lathes. This speech is intended to introduce the not so technically versed individuals to machine tools and how they have and what they have done for our modern society. Here's a preview of the main points. Recent history on machine tools. Preview of the main components of a lathe. And then machining 1018 steel. Let's get started and jump right in to the main points of this speech and what it has to teach you. Now on to my first main point. My first main point is on the recent uprising and history of machine tools and what they have done to create our modern world. Here's an excerpt from the article Technical Evolution of the Machine Tool. In the 17th and 18th centuries, the makers of clocks and scientific instruments used lathes and machinery of threading precision. Highlighting the lathe for threading of Jesse Ramsden, built in 1777 in support of an iron triangular cutting tool, was placed in the carriage, which could be slide longitudinally, with a crank operated by hand and through a set of gears to turn the piece in threading placed between points at the same time by a means of screw thread pattern was achieved. So this is a technical evolution of machine tool historical notes. I have just discussed and informed my first main point, the history of machine tools. Now on to my second main point. My second main point is on the main components of a lathe and how they work together. This is an excerpt from the article Anatomy of a Lathe. Just bought a lathe and feeling a touch in awe of it? The first thing is then to familiarize yourself with what is what around the lathe. So, Nigel, Anatomy of a Lathe. So, I actually have this manual right here for this lathe. And it has it all chunked up into the main components. So the headstock right here is kind of like the heart of the lathe. It's got the spindle, it's got the headstock pulley, back gears, that sort of thing. And that's what drives. It's what basically makes the machine move. So here we have the countershaft assembly, and that takes the power from the motor or whatever else spinning and through pulleys and belts and drives the spindle. So then all that is mounted on the lathe bed. And the bed is kind of like the backbone. You could think of it as like a spine of the lathe. It's what keeps everything parallel, concentric, perpendicular. So, and then right here, we have the carriage assembly. And this rides along the bed, and while the headstock is spinning, it can cut material off whatever material you're machining. And then through all the rotation there, this is the lead screw, and it is mounted on the lathe bed, and it drives the carriage assembly. So it's all kind of like an automated process. So here, if we take a look, I have my lathe right here. It's the same one basically, but we have this 3-jaw chuck right here. We have our carriage assembly with our tool holder. This is the headstock. We have the countershaft assembly, and then we have the motor. So up here is a reversing drum switch, and it changes the rotation of the motor so we can go forward or reverse. So actually I'll turn it on for you. So this is forward. So see how it's spinning that way? That's forward. And then reverse is spinning the other way. So yeah. And then right here we have this little selector knob. It changes the reverse of the rotation of the lead screw down here. And when we put it in this top position, it's going to feed the carriage that way. So if you keep an eye on the handle here, we have this little half nut lever. So when I turn it on, you hear the noise. So when I engage it, look at the handwheel. Now it's spinning. If you had a workpiece in there, it'd be taking off material. So yeah, that's a lathe. Now, on to my last main point. My last main point is on machining of 1018 steel. It's a low carbon steel. This is an excerpt from the PDF article on mild steel. Alloy 1018 is the most commonly available of all the cold rolled steels. It is generally available in round rod, square bar, and rectangle bar. It has a good combination of all the typical traits of steel. You got strength, some ductility, and a comparative ease of machining, which we like. Chemically, it is very similar to 836 hot rolled steel, but the cold rolling process creates a better surface finish and better properties. So this was from Eagle Steel. So right here, I've got a little slug of 1018 cold rolled steel, and I actually machined it on here. So see how this is kind of like a dark ring around here? This is what the surface looked like before. Then we're down to machined surface. So this is 1018 cold rolled steel. I have just discussed the history of machine tools, the main components that make up a lathe, and the machining of low carbon 1018 steel. So next time you get into your car, or when you enjoy the convenience of automation, just remember that all this modern precision came from machine tools like the lathe, and more particularly, it all started with the lathe. So yeah, I hope you learned something today. This is all about machine tools and how it has created our modern world. So thanks for watching.